Go through the problems pretty quick. You can always pause the recording if you need to. For question number 1, the first thing it says is to actually draw a segment AC and have B between them. B in between does not mean it's a midpoint. And it asked me to find X, the length of AB, and then to indicate if B is a midpoint. So determine, is B actually cutting this segment in half? They told me that AC was 5x minus 24. They told me that BC was x plus 9. And they told me that AB was 2x minus 5. And I put that information into my picture. From there, I can see that segment addition. I can take part of the segment, add the rest of the segment. So 2x minus 5 plus x plus 9 should be equal to the whole thing, 5x minus 24. Combine like terms, 2x and x is 3x. 9 and a negative 5 is 4, equals 5x minus 24. Combining a couple of things here, I'm going to go ahead and subtract 3x from both sides, but I'm also going to add 24 to both sides just for the sake of time here. I now have 28 is equal to 2x, and when I divide both sides by 2, I get x equals 14. There is part of my answer. If I plug 14 back in to find AB, AB is supposed to be 2x minus 5. So if I replace or substitute in the 14, I have 2 times 14, which is 28, minus 5, which would be 23. So I now know that this length is 23 units long. If I plug it in here, I'd have 14 plus 9. So I can also see that this is 23 units long, which is why B is a midpoint. Number 2, need to make sure that we draw a figure. We have segment PQ. It said E is a midpoint, and the biggest mistake that students make is they don't mark when it's a midpoint that it cuts this into 2 congruent pieces. They said PE is 3x minus 4. I'm going to put that in my picture. They said PQ, the whole thing, was 5x plus 4. Now it looks like I'm missing a piece, but because they told me that this was a midpoint, if this is 3x minus 4, over here is also 3x minus 4. And it then is very similar to the first problem. I can add the two pieces together, 3x minus 4 plus 3x minus 4. Should be equal to the entire thing, 5x plus 4. Again, combining like terms, 3x and 3x is 6x. Negative 4 and a negative 4 is a negative 8. And going ahead and doing a couple steps again at the same time, I'm going to go ahead and subtract 5x, but I'm also going to add 8, and I can see that I ended up with x is equal to 12. And this is all they asked for here. What is the value of x? Number 3, it says look at the figure. AE equals 3x, so from A to E is 3x. They said ED was 2x minus 3, but they told me AC was equal to CE was equal to ED, so I know all 3 of these pieces are the same. So because this was 2x minus 3, each one of these pieces is also 2x minus 3. And I can see that if I add these 2 pieces together, it should be equal to the whole thing, which is 3x. 2x minus 3 plus 2x minus 3 is equal to 3x. Combining like terms, I have 4x minus 6 equals 3x. I am going to go ahead and subtract 4x from both sides. I now have negative 6 equals a negative x. So when I divide both sides by a negative 1, I get x is equal to a positive 6. They also asked me to find CE. CE was 2x minus 3, which means I can replace this with the value I found for x. 2 times 6 minus 3. 2 times 6 is 12. And 12 minus 3 is 9. Two lines intersect to form a point. If you're ever in doubt, just draw two lines on the sheet of paper and look at the intersection. What does this represent? And it does represent a point. 3 points are coplanar. Remember that we name a plane with 3 non-collinear points. Since I name a plane with 3 non-collinear points, then any 3 points will always be coplanar. 3 points are collinear. Well, I could make 3 points collinear. Here's 3 points. They would be collinear. But it's also possible that I could have 3 points that look like this, and you can see that these would be non-collinear. So this would be sometimes. Vertical angles are congruent. That is one of the theorems that we talked about and even showed you how that works, but we know that vertical angles are always congruent. Supplementary angles form a linear pair. This is sometimes. Here's an example of where they do. There's a linear pair, and if I told you that this was 100 degrees and that this was 80 degrees, you can see that they add up to 180. But they could have also been drawn like this. This is 100 degrees. The other angle could have been down here. Maybe this is 80 degrees. But when I add these together, they still make 180 degrees, so they're still supplementary. But they're no longer linear. That's why this is sometimes. 9, 10, and 11 use the same picture, so I'm going to put information in the picture and erase it when I go to the next problem. EBC equals 120. So from EBC, this whole angle is 120 degrees. Angle 1 is 2x plus 5. Angle 2 is 3x plus 15. Using the angle addition postulate, I should be able to add these two pieces together then and set them equal to 120. So the equation would be 3x plus 15 plus 2x plus 5 equals 120. Combining like terms, I have 5x plus 20 equals 120, which means 5x is equal to 100. Therefore, x is equal to 20. That's the first part of this problem. The second part says find angle ABD, which would be this angle that's here. The problem with finding this angle is they gave me no information about angle 3. But since I already know that x is 20, I can actually plug that back in. 2 times 20, which is 40, plus 5. So I know the piece of this angle over here is 45 degrees. And when I put them all together, it would have to add up to 180. So this is 180 minus 45, which is why angle ABD is 135 degrees. Now, erasing the information that I put in the picture so that I can do number 10. Number 10 said angle 1 is 35. They said angle 1 and 3 are congruent, so I'm going to mark that. And they said find angle 2. Well, if 1 is 35, angle 3 is also 35. And I know that when I put all three of them together, they'd have to add up to 180 degrees. 35 and the 35 put together is 70, which means that angle 2 had to be 110 degrees. So when I add them all together, they are 180. Again, erasing the information from the picture, going to the next problem. Angle 3 is congruent to angle 2. Make sure if they give you information about a picture that you mark that information into the picture. 3 and 2 are the same. Angle 1 is 2x plus 2. And angle 3 is 6x plus 12. Since angle 3 is 6x plus 12, angle 2, which was congruent, would also be 6x plus 12. And I should be able to then see that if I put all three of these together, they have to add up to equal 180 degrees. So I have 6x plus 12 plus 6x plus 12 plus 2x plus 2 is equal to 180 degrees. Putting together my like terms, 6x and 6x is 12x, and 2 more x is 14x. 12 plus 12 is 24, plus 2 more is 26. If I subtract the 26 from both sides, I now have 14x is equal to 154. So when I divide both sides by 14, I get x is equal to 11. That's this first part. They said find angle 2, so I can actually go up to angle 2 where it is. The measure of angle 2 was 6x plus 12. And where x is, I can replace it with 11. So I have 66 plus 12, which is a total of 78. So this is 78 degrees. Number 10 says draw a number line. Said label point A as being a -7. Label B as being -5. Label C is being 2. Label D is being 6. Label E as being 12. Okay, they said find AE. Distance formula on a number line says the absolute value of A minus B. In other words, the coordinates of A and the coordinates of E in this case. Absolute value, -7, minus the coordinates of E, which was 12. -7 minus 12 more would be a -19. And the absolute value of a -19 is a +19. To find the midpoint on a number line, you take the coordinate from the first point, the coordinate of the second point, and divide it by 2. The coordinate of A is a -7, plus the coordinate of C, which is 2, and you divide that by 2. So I get a -5 over 2, and if you put that as a -2.5, that's certainly okay. Either one of these would be acceptable. You must have these formulas memorized, distance and midpoint, for both the number line and the coordinate plane. Distance is equal to the square root, parentheses x2 minus x1, parentheses squared, plus parentheses y2 minus y1, parentheses squared. Midpoint is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. So, on the distance formula, I have the square root, and x2 minus x1, so I have 5 minus a negative 3 squared, plus y2 minus y1, 7 minus 4 squared. The minus a negative is going to change to plus a positive, so I have 8 squared. 7 minus 4 is 3, so I have 3 squared. 8 squared is 64. 3 squared is 9. So I have the square root of 73, or approximately square root of 73, 8.5 I believe. .54. If they said round to the nearest tenth, I'd put 8.5. It's actually 8.544. So if they said round to the nearest hundredth, I could leave it like it is. So approximately 8.5 to the nearest tenth. Midpoint, I would take a negative 3 plus 5 divided by 2, and I would take 4 plus 7 divided by 2. Negative 3 plus 5 is 2. And 2 divided by 2 is 1. 4 plus 7 is 11. So you might have 1 and 11 over 2. You might also have 1 and 5.5. Either would be okay. On the next problem, they give you one of the endpoints, but they also give you a midpoint. So you got to take the midpoint and replace it with 1, negative 3. And you replace one of your x's and y's. Negative 5 plus x over 2, comma, 2 plus y over 2. From here, two equations are going to split out. The x equation, 1 equals negative 5 plus x over 2. And then the y equation, which would be negative 3 equals 2 plus y over 2. We're going to do the same procedure in both. I'm going to multiply both sides by 2. I'm doing it to get rid of the fraction. They cancel out. I now have 2 equals a negative 5 plus x. And adding 5 to both sides, I get x is 7. Multiplying both sides by 2, I get a negative 6 equals 2 plus y. Subtracting 2 from both sides, I get y equals a negative 8. So the endpoint is the ordered pair 7, negative 8. Again, 16 and 17 are using the same picture, so you'll see me put information in the picture that I end up erasing. Angle AFE is 59 degrees. Angle CFD is 104 degrees. How big is BFC? So here they're looking for this angle, and I know that this angle and this angle are exactly the same because they're vertical, so this is 59 degrees. AFE is 4x plus 10. AFB is 4x plus 30. I should be able to see that they've given me two angles that form a linear pair. So I'm going to take those two pieces, 4x plus 10 plus 4x plus 30. I'm going to add them together and set them equal to 180. 8x plus 40 equals 180. 8x then is equal to 140 by subtracting the 40 from both sides. And when I divide by 8, I get x is equal to, and it comes up to 35 over 2 when it's reduced, or 17.5. They're looking for angle BFC. Because these two angles are the same, this would be 4x plus 10. So the angle that they're looking for, the measure of angle BFC, is 4x plus 10. But since I know the value of x, I can actually substitute that in. 4 times 17.5 plus 10. And when you work this out, this actually comes up to 80 degrees. Okay, name the property that's illustrated. To get from here to here, they had to divide both sides by 7. This is the division property of equality. If AP equals PQ, then PQ equals AB. Notice these actually switch sides. Come on in.
Do you want to keep the flags in your window?
Absolutely. Okay, had a small interruption, but you'll notice that AB is equal to PQ, and that over here that they've switched sides. That is the symmetric property of equality. Angle 1 is equal to angle 3. Is a measure if angle 1 equals 30. It says the measure of angle 1 equals the measure of angle 2. So the measure of angle 2 is equal to 30 degrees. So they're saying that where this angle 1 is, that I can replace it with this angle 2. This is the substitution property. If you know two things are equal, you can replace it. This one is the reflexive property, and it is, notice that we're not talking about equality anymore, we're talking about congruency. There's a small difference. And some people would think that maybe it's changed order, but here's what I want you to think about. Here's R, here's L, and here's M. So there's talking about angle RLM, or this angle that's here. And then they say angle MLR. All they did was go in a different order, but they're still talking about the same angle. So this is the same as A being equal to A, because they're talking about the same thing, which is why it's reflexive. With this particular problem, I really recommend that you kind of forget about a piece of it being there. I'm just going to kind of cover a piece of it up for the moment, because this piece has both an X and a Y in it. So I'm going to cover it up for a minute. From here, you should be able to see that these two have to add up to equal 180. So you'd take 11x plus 8 plus 5x minus 4 and set it equal to 180 degrees. And we're going to just solve this for x the same way we solve any algebraic equation. 11x and 5x is 16x. 8 and negative 4 is positive 4 equals 180. Subtracting 4 from both sides, 16x is equal to 176. And dividing both sides then by 16, I'd get x is equal to 11. Okay? If x is equal to 11, when I come back over here to my problem, I can plug that in. I have 5 times 11 minus 4, or 55 minus 4, which would be 51 degrees. and I'd have 2 times 11 plus 4y, or 22 plus 4y. And I know that these two have to be equal in measurement because they are vertical angles. So I know that 22 plus 4y is equal to 51. Subtracting 22 from both sides, I now have 4y is equal to 29, and I would divide both sides by 4. Y equals 29 over 4. I'm certainly okay if you leave it that way. If you changed it to a decimal, what you would have is 7.25. And certainly either way would be okay. The two proofs. The first proof is strictly algebraic. They gave you this information. Take a look at what's there. To get from here to here, they obviously took this x away. They put their x's together. That is the subtraction property of equality. To get from the next step, they took 8 away from both sides, also the subtraction property of equality. And the last step, they had to divide both sides by 3. This is the division property of equality. In number 1, they gave me the reason. They said it was given. Angle Z is congruent to angle WBZ. Anytime they use, let's see here, they're using the definition of vertical angles. I'm going to mark this in the picture, by the way. Angle Z right here, WBZ right here. They said definition of vertical angles. Well, the only vertical angles that are here are these two. So I'm going to go angle WBZ is congruent to angle XBY. Okay. Now, if you take a look, where this one stopped, this one picked back up. So they went from here all the way to here. And this is the transitive property. They are using congruency, so it's really the transitive property of congruency, but if you have transitive, I would not take off of that. If they use a definition of congruence, you have to go from congruency to equality or from equality to congruence. So here they're saying the pictures are the same, but I want to say that the measurement of angle Z is equal to the measurement of angle XBY. And I can do that because of the definition of congruent angles. If you take a look at where angle Z was, it was 10x minus 20, so they replaced angle Z with 10x minus 20, and they replaced XBY with 6x plus 4. So this is the substitution property. They actually also changed sides of where it's at. So it really combined two steps. This would also be symmetric. Number 6, they said they used the subtraction property of equality. Well, since they did subtraction, I could have said that I subtracted 4, or I could say I subtracted 10x. It really wouldn't matter. Your next steps would just look a little different. I like to put my x's together first, so this gives me a negative 4x plus 4 equals a negative 20. I would still want to get my variable by itself, so again I would use the subtraction property of equality. And I would subtract 4 from both sides, leaving me a negative 4x equals a negative 24. And my last step would actually be the division property of equality. And it would be x equals a positive 6, which is really what I had written up here on your sheet today, is prove that x equals 6. Hope you find this helpful. Good luck. Make sure that you study a